Welcome, everybody. Thank you for joining us tonight. My name is Grace. I'm with Project APIS-M. For those of you who may not know, PAM's mission is to fund research and efforts to improve honeybee health and vitality. Just real quick, can everybody hear me? Let me see a couple of thumbs up. Okay, great. So we have a mix of new beekeepers, professional beekeepers, and pretty much everyone in between here tonight. There are also some bee researchers and bee educators. It's great to see some familiar faces. The project Dr. Vanessa Corby-Harris is presenting tonight is part of our Healthy Hives program, advancing measurable, tangible solutions for beekeepers. Funding this project on nutritional supplements was a direct result of discussions with beekeepers about what information would benefit them the most. Now I'd like to hand this over to Dr. Timothy Fredericks, who will talk a little bit more about Healthy Hives and introduce Dr. Corby-Harris. Tim is a researcher and avid beekeeper, currently focused on environmental engagement at Bayer Crop Science. Tim also is involved with the Honeybee Health Coalition and is the past president of the Three Rivers Beekeepers. Tim?
Thanks, Grace. Glad to be here tonight. Thanks for that introduction and for getting us started. I'm glad to see so many people joined us and joining us still tonight for this presentation. As a beekeeper, as a proponent of diverse blooming habitats, and as a scientist working directly at the intersection of agriculture and pollinators, I'm excited to be a part of helping to drive the Healthy Hives project through Bayer Crop Science and Project APIS-M. I've included some of the highlights from the first 6 years of the Healthy Hives initiative on this slide. The program started in 2015 as Healthy Hives 2020, and over the first 5 years, it funded 13 projects on topics ranging from Varroa and associated viruses to specific tools for beekeepers like the indoor storage guide that is available on the PAM website. In 2021, we extended the research funding for an additional 3 years and renamed the program Healthy Hives. We are looking forward to continuing to fund research projects over the coming years. The research conducted through Healthy Hives has had a dramatic and tangible impact on the future health of honeybees, as well as the viability of beekeeping, both of which help to enable the world's food supply. Often the projects have partnered researchers with commercial beekeepers. It's a win-win partnership that keeps the research focus on solutions for beekeepers. Tonight's presentation by Dr. Vanessa Corby-Harris is a great example of this type of partnership with the commercial beekeeper Blake Shook of Desert Creek Honey. We as beekeepers are always looking for practical solutions to improve the health of our colonies, and protein supplementation is definitely a hot button topic among beekeepers. I'm looking forward to Vanessa digging into the details of the different pollen supplements tested and the associated measures of hive strength and health, all while keeping in mind the economics for a beekeeper. Now I'll hand it over to Vanessa for tonight's main presentation.
All right, well, thanks, Tim and Grace for that introduction. And thanks to all of you for attending this webinar. So again, my name is Vanessa Corby-Harris, and I study bee nutrition, honeybee nutrition, and physiology at the USDA Bee Lab in Tucson, Arizona. So today I'm going to tell you about the results that we are getting, obtained already, that we're getting in every day, and that we're analyzing from a trial that we did thanks to this Healthy Hives and PAM funding. And before I get too far into the talk, I want to recognize them and thank them because this trial would not have been possible without their help. I also want to thank our collaborator, Blake Shook, who supplied the hives for this study and worked with us throughout the trial. I want to also thank my collaborator, Gloria DeGrande Hoffman, and our field techs, Lucy Snyder, Henry Graham, Emily Watkins de Jong, Mona Chambers, and Charlotte Metter. You might recognize some of those names. So before I get into the nitty-gritty of the experimental design, I do want to spend a little bit of time talking about colony population dynamics throughout the year. And some of you might have seen this graph. I took it from, or well, I didn't steal it from her, but she generously lent it to me, Gloria DeGrande Hoffman. So here we have this is a figure, and it is showing you colony size of a colony that's kept outdoors through the year in Illinois in 1903. And in this model, we used historical weather data and the Varroa Pop model to model the population dynamics of this colony. And under this model, there's a few assumptions made. The first one is that adult age is related to flight hours. And the second is that the queen's egg laying depends on temperature and photo period. So in short, this means that cold days that are short prevent forager flight and queen egg laying, so in the winter. When you put weather conditions from this location and date into the model, you can see, can you see my pointer there? Is that coming up?
Yes.
Okay, perfect. Okay, you see that colony size, it rises in the spring until you get to about September. And then the colony population starts to sort of drop as the queen's egg laying starts to slow down. But things, they do cool down when you're moving into the fall. And so the bees tend to not fly as much in this period in the fall. That is when it's below 55 degrees at least. And then at the end of November, the weather gets cold enough and it stays cold enough to prevent flight altogether. And so this, so during this period of the late fall and into winter and then early spring, the adults form a winter cluster that has these winter bees that have a long lifespan, and there's not a whole lot of brood being made. There is some evidence that brood is made, but at least under this model, it's very minimal. So the queen starts laying in the late spring as the weather warms up and the days lengthen. But egg laying and brood rearing are still kind of slow compared to the peak of brood rearing that we see in the spring and the summer. Towards the end of March and into early April, the weather warms above 55 degrees. And of course, there's flight during that time, forager flight. But despite the queen laying eggs, and she actually started a couple weeks earlier because of this increase in photo period and temperature, there's not really enough adults yet, though, to counteract the loss of those adults that have started to forage more during the warmer days. And so what you get, is this pattern of spring dwindling going on here. And eventually the aging adults are replaced by those first few cycles of brood, and the population can take off again. So this is a colony at that same location that's kept outdoors, but with more current weather patterns. And as in the previous graph, you see this rise and fall going through spring and then into fall. And as the weather cools at the end of November, the adults will, the adults do form a cluster. Sorry, I'm trying to get my pointer here. Do form a cluster and winter bees are produced. But there are still some warm days during this time leading into November in the fall. And also there's some warm spells going on here in December. And so you can still have flight happening in later fall and also at periods in, throughout the winter. And so because age is determined by flight hours in this model, whenever it warms up and the foragers can fly, those foragers will age. Because they age, that means that some of them will eventually die and the population will decrease. But another thing that's happening is that age also means that the bees are weakening, essentially. And so this population here, this flat line here, the population is frozen in time, sort of like the numbers are frozen, right? But what is happening in this cluster is that because of this flight weather that happened earlier on in the year, some of those foragers aren't doing so great because they're getting old. So as we get into mid-March, the weather starts warming up for good. Okay, but because of this extended period of flight in the fall and those warm spells, there's not enough young, healthy adults that are really left in that cluster. So during this time, you have a period where there is some new brood being produced, but that queen can't produce enough individuals to replace the ones that are dying. And in addition to that, the ones that are there are actually really old and they're dying really fast. They're dying faster. Okay, so what you have here, going on here, what was spring dwindling has now become a point of no return and the colony fails. So for the last few years, our center, not only my lab, but the MECO lab, the DeGrande Hoffman lab, we've been working on various questions related to cold storage. And one motivation for this was this very question of spring dwindling. And again, under the models that I talked about, hives wintered outdoors are weakened by these warm spells, increased periods of flight weather in the fall that we're seeing more and more. And again, our initial models suggest that this was a bad thing related to that will eventually predict hive failure. But we're also analyzing this in the context of cold storage, and our models initially suggest that cold storage may actually stabilize that winter population and keep them young in preparation for the spring. Okay. And so that's kind of the genesis, or well, it's the motivation for this study, this data that I'm showing you here. And so this is a graph showing you the results of an experiment where this was conducted in 2019 and 2020, where all these colonies were kept in North Dakota, and they were placed into cold storage either in October or November. And they were measured for colony size or seams of bees at 4 different time points: early September, late January before almond bloom, and late March after almonds. So again, all of these hives were put into cold storage just at different times. And the last 2 time points show evaluations that happen after cold storage. So what we find is that hives placed into cold storage earlier in October, so these gray ones, these gray ones, so this is fall, went into cold storage, everybody loses frames of bees, but the ones that are put in earlier, they maintain their population, okay? The ones that are put in later, you still get a little bit of dwindling, okay? The interesting thing here is that we don't think that the stability of this colony population that I'm showing you is explained only by emerging brood, because the brood population has not really increased enough at that point to replace these winter bees or the adults that are left over from the fall. Instead, we think that this says something about how putting colonies into cold storage earlier increases the longevity of the adult population until those newly emerged bees can replace them, okay? So really what we're doing is we're not letting them fly because we're putting them into cold storage earlier, and so they don't age as fast, okay? So I'm telling you all of this to sort of whet your appetite for this concept that the strategies that we employ in the fall are very important for making our bees healthy going into cold storage, and also to prevent the hive population from dwindling too much as they come out of cold storage and go into early blooming crops like almonds. So I'm now going to tell you about some of the work that we did for this trial. And this work started out as only a diet study, okay? But it became a diet and cold storage study because Blake, our cooperator, decided that this is something that he wanted to try out, this cold storage. And that was fine by us because this actually dovetailed nicely with some of our ongoing research on cold storage. And so what we ended up looking into was not only how these diets compared, but how the diets compared in the context of preparing your hives for cold storage. So here's our experimental design, okay? So we had colonies in 2 replicate yards, and in each of those 2 yards, we divided up the colonies by 6 evenly. And we fed each of those 6 groups a different diet, a different commercial diet. And they're color coded here, and I'll also have some color coding in subsequent graphs, but here you go, here they are. So the positive control was a global patty with 75% pollen. This was specially made for us. The remaining 25% of the diet has to be there. We can't make it 100%, or we can't make it like have more pollen in it, because it needs things to keep, you know, sugar and water and other things to keep it together. And we were lucky enough to have them be able to make a large amount of pollen, you know, of our special recipe. So we were grateful for that. There's no negative control. And the reason for that is because we know that when we don't feed hives anything in the fall, the colonies die. Okay, so we already know that. And we did not want that to happen to Blake's hives. We didn't want to kill 60 of his hives in total. Otherwise, you'll see 5 commercially available diets. I want to thank, of course, the people at Global Patties, like I said earlier, for helping us with those. But I also want to recognize and thank Gordy Wardell of Megabee and also Man Lake for providing us a really substantial discount on things like Megabee, Ultra B, and B Pro. The cost of each diet per pound for a pre-made patty is shown, okay? And I just took that, that's the list price. If you had a pre-made patty, the cost of each 1 pound patty, if you were to buy a 40-pound piece. Okay. And you'll also see 2 numbers at the bottom here of each square. The larger number is the total number of hives that we placed into each yard and fed each treatment, okay? And we measured all of these hives for seams and bees. The number in parentheses are the hives that were part of a smaller set of this larger group. So we took about 1/3 of them, and we took more detailed measurements of these hives. I'll talk about that more in just a little bit. So now it's some story time. So the study was conducted on hives that spent their fall in North Dakota before going to cold storage. I do want to note that it was surprisingly warm in North Dakota during our fall trips, like the August visit. In the middle of August, I think it was up into the mid-90s at like 5 o'clock at night. And as all of you may know or will know, there was a drought there during that time. Despite the drought, there were a lot of sunflowers, wild and cultivated, in bloom for that first year, especially. And there were a lot of other just wildflowers along the margins of the different drainage ditches and such. So after cold storage, all of the hives went to almonds, just south, I think it was just south of Fresno. And so we logged a lot of miles making those trips. We did have to drive on all 4 trips. And this is a picture of the fender that got all messed up after we hit a deer in North Dakota. So that was kind of fun. Well, I say that in a very sarcastic way. So picture three people trying to change the tire on a Suburban on the side of the road in North Dakota in the middle of nowhere. And that was us after we hit these deer. So that was interesting. So here's just kind of like a timeline of when we evaluated and fed our hives. So we evaluated the hives 4 times in fall of 2021 and spring of 2022. The first evaluation happened before any diet was applied, and then diet was immediately applied after that after that first evaluation. Diet was applied weekly at 1 pound a week for 4 weeks before this before cold storage. And we fed for 4 weeks because that was the limitation of when the honey, it was between when the honey was pulled and when they went into storage. And during this time, the hives did consume most of their diet, or actually all of their diet at that point. We also didn't observe any pollen around the brood area in the hives at this post-feed late September measurement. So we suspect that there was not a whole lot of natural pollen in the area. And I say this because in my experience, bees won't eat patty if they're getting enough pollen from their environment. So based on what Blake's crew was telling us and what we saw in the hives, they ate everything that we gave them. So that was important. The hives went into cold storage, and then when they came out of cold storage, they went directly into almonds before the bloom. There were buds on all of the trees when the hives were dropped. At this time point, we evaluated everybody, and then they were evaluated 3.5 weeks later during the bloom. At this point, we noted that the hives had been graded by the grower's inspector. We took those last measurements and we could see their evaluations on the top of the hive. Okay, so again, I just want to remind you that I told you about these two groups of bees. One is a subset of the other. For this larger group of 352 hives, we collected data on seams of bees for everybody. And I'm going to talk about those data first. So what I call seams of bees, some call a cluster count. Henry, one of our field technicians, calls that a California count. I don't really know what the right name is, but suffices to say that this is a pretty coarse measure of frame coverage within the cluster. We do this when it's cool enough so they're still sort of in the middle part of it. So here's a picture of Henry doing those seams of bees. And this method, while it yields less information, it's considerably faster. And so you can do a lot of queries. A person can do a lot of queries within a short period. We did all of these counts at all first. That first time point before Blake's crew did that first. Again, we were able to create a lot of using this 350 or more. I also want to mention that we use this information first to the hives and to target local hives, and also pull or take away weak hives. So not all of those hives end up being something that we could use. For the most part.
Vanessa, I'm so sorry to interrupt. We can't seem to hear you just for that last minute or so. If you don't mind, maybe. Yes, that is much better. Thank you.
Oh, sorry about that.
I'm not sure what happened, but if you could just maybe start over on this slide, it was about the last minute or so.
Sure. My apologies. Okay, so what I'm referring to seams of bees, that's the measurement that we took on all of our hives. Okay, some people call it a cluster count, some people call it a California count, but essentially it's an estimate, it's a rough estimate of coverage, frame coverage, if you crack open the hive and you look in the middle of the cluster. Okay, and that's a picture of Henry doing that. So this method, although it does yield less information, it is a lot faster. And so it allows us to evaluate a lot of hives in a lot less time. Henry did all of the counts, all of these evaluations for the last 3 time points, but for the first time point, Blake's crew did that. And we actually used that information, other than just the count, to assign treatments. So we randomly assign treatments across all of the hives. But when I talk about that subset or focal subset of hives, we actually picked the strong ones to do that. We did that on purpose, okay? And we did that because these full measurements can often be hard on colonies. And so we didn't want to, purposely kill colonies when we knew that that would have been a lot for them to handle. But this was something that we did account for in the analysis. So just a note on sample size here. For that larger group that we took seams of bees data on, we started out with 378 hives, and there were some hives, 26, there were 26 hives that died between this pre-feed and post-feed evaluation. If a hive died during this post-feed evaluation, we took it out of the data set, assuming operator error. 9 hives died in cold storage, and 5 hives died in almonds. 27 hives were lost, which was unfortunate, but it happens, and we treated this as missing data, not as a colony failure, okay? So what factors influence seams of bees? So I used a repeated measures analysis, a repeated measures ANOVA, to be more specific, to look at whether seams of bees at these time points were predicted by diet, whether or not we did a full evaluation, because again, this is harder on the hives, and the interaction between these two factors. Replicate yard was a random effect, and it's worth mentioning that we did see consistent differences between the yards. And these apiary-based differences are consistent with what others have seen. Okay, so here's a graph of what we saw, and I'm going to take you through this graph. So on the x-axis, we have our different diets. Okay, global 75% was the positive control. On the y-axis, we have seams of bees. And this is basically a time series of those 4 different points where we evaluated the hive, separated by diet. Okay, so for Bee Pro, we measured them August, September, January, and February. Okay, we did the same thing for everybody. Okay, so a few things to go over. We did see that everybody lost bees in cold storage. Okay, this is to be expected. And in general, the loss was roughly equal among the diets. We did see that in almonds, the populations either stayed, so between these last 2 time points, the populations either stayed the same or increased, okay? Suggesting that at least cold storage and possibly also feeding your bees can prevent spring dwindling and actually help with growth in almonds. In fact, there were 4 out of the 6 treatments for Bee Pro, Ultra B, AP23, and Global, 4%, Global 4%, where the groups actually gained, the population size actually increased in almonds. We did see that diet-based differences started to emerge by the last time point during almond bloom. So I have some asterisks up here, okay? And what these asterisks are showing you are significant difference in seams of bees at this last time point between each diet and the positive control. So we did see that colonies fed megabee in the fall had fewer seams of bees in almonds compared to this positive control, okay? While colonies fed the global 4% diet trended towards having more bees. And this was not significant at the 0.05 level, but it was like 0.07 significant. So any of you that are familiar with statistics, that's definitely a trend, but not wholly significant. Okay, but we did see that there was an effect of diet overall at this post-almonds point, at this last time point. So the diets did differ. We also sort of broke it down, and if we just look at the number of frames of bees in almonds, so this was at that 4th time point. If we just kind of break it down and I give you the the average seams of bees and almonds. We did have the, let's see, so this is the positive control in purple. The global 4% diet tended to have about 1.5 frames or seams of bees more than the positive control at this last time point. And the mega bee had 1.9 fewer seams of bees at this time point. With respect to just survival through cold storage, we wanted to take a closer look at that. And so for the most part, most hives did survive the cold storage. Okay, so they did come out in January alive, an average of 97% survival overall. But to look at this mortality more closely, I wanted to ask whether the diet that the hive was fed or the hive size in September immediately going into cold storage, whether those two factors, in addition to the random effect of yard controlling for that, whether diet and hive size in September predicted whether or not a hive would die in cold storage. And so under this model, diet did influence survival after cold storage, or survival in cold storage, let's say. So with hives fed the AP23, had the highest mortality, but still, I mean, they're surviving 91% survival. So only 5 out of the 57 died here. So still a small number, but significantly different than the control. But this does come at a cost. So I'm now going to sort of shift gears and talk about this smaller subset that we did the full evaluation on. So not only did we get information on seams of bees, but we got a lot of other detailed measurements. So this is a group of 120 hives, again, evenly split among yards and the diet. So this is a picture of, this looks like Lucy, and I think it might be Mona, taking these data, doing these full evaluations. And here they're working on, it looks like the top box. And you can see just from the activity of bees around here that this is a fairly disruptive process. Okay, so that's why we don't like to do it on all the hives if we can help it, because it can be a bit, there's a lot going on out. So this is the list of parameters that we measured in this smaller group of focal hives. And I have given you a list here, but then also sort of our progress report on it. So these first 2 bullet points here are pretty easy to measure. Let's see here. And so that's why we have data from all 4 trips for those measurements. For example, this is a frame face, and the way that we do the frame coverage estimates is that we divide each face by 5 slices, and we say, okay, how much pollen is in there, how much brood, and how much is empty. And then we also say how much of this frame is covered by bees. And you get pretty good at it after some practice. So for this, I would say that this face has maybe 1/5 pollen, 3/5 brood, all sealed, and 1/5 adult coverage. And we repeat it for the other side and do all of the frames in the hive. The last 3 bullet points, they take a little bit more work. We did do alcohol mite washes. I talked about that. That's pretty easy. And that's pictured here. This is actually the same type of method that we used with these mite check containers. And the good thing about the alcohol washes is it can give you an exact measure of mites per 100 bees or percentage, right? Rather than a sugar shake where you're trying to get enough bees in there and you're trying to eyeball it. But this, we know exactly how many bees we sampled. And this is a picture of nosema. Many of you might be familiar with this picture here. So we take nosema measurements. We sample 25 bees from the outer frames. And then we take those 25 bees and we take out their guts and all their abdomen stuff, and we crush it all up together, and we get a measure of nosema levels for each. Last, we also took information on fat body nutrients, so lipid and protein levels. So this is a fat bee, this is a non-fat bee, and actually these little dots here are the fat cells or fat globules. We dissect 10 bees per colony, and we take all of the bees out of the brood nest. So this takes some time. And out of the first 2 trips total, we've dissected about 2,100 bees so far. And the reason why we go through this much work is because it yields some interesting data, and I can talk about that in a second. And in addition to getting more information on the hives, another good thing about taking all of these measurements together is that we can eventually use these as predictors in our statistical analysis to look more closely at how these factors, in addition to diet, influence hive size post-storage. So as in the earlier analysis, we used a repeated measures analysis, or repeated measures ANOVA, to look at whether adult bee frame coverage at these time points and also seams of bees was predicted by diet. However, because we had so much more information on these hives, I could also look at factors like whether the mite count in August and September was above 2%, whether nosema in August and September was above 1 million spores per bee. These are actually your treatment thresholds, depending on time and things like that. We were also able to look at change in fat body lipid between August and September, change in protein levels between August and September. So we can put all that into our model and ask whether these factors influence hive size. And so again, I just want to sort of tell you a little bit about sample size here. We started out with 121 bees. A few bees, or a few hives, died in during this feeding period, and so we took those out of the model. So there were 109 bees going into cold storage, and let's see, 3 of these hives died during cold storage, and then we had 1 hive that died in almonds and another 9 that went missing. So 96 hives made it through the whole experiment. Just to give you a sense for the size of our study. So again, I'm going to show you a graph where on the x-axis we have diet and we have seams of bees on the y-axis. This is just the time series where measurements were taken for the different diets: August, September, January, February. Okay. Last 2 are after cold storage, first 2 are before cold storage. And a few things to look for here. As with the larger data set, everybody lost bees in cold storage. That's to be expected. However, coming out of, sort of after this cold storage and going, through some almond pollination, you can see that populations either stayed the same or in some cases they also went up. Okay. But using this metric of seams of bees, and after accounting for all of the factors that I mentioned, diet, proteins, lipids, nosema, and mites, we did not see that diet predicted colony size or that it affected colony size. So it was non-significant. However, what was important was mites. So I want to talk about this just very briefly. If the mites were above this 2% threshold in August, we did see that there was a difference in seams of bees compared to the ones where mites were controlled or below this 2%. Okay, so I want to stress that this was in August. Okay, if this was the mite count in August, and in Blake's hives, we saw no mites in September. Okay, so it seems that the mite count in as early as August is predicting differences in seams of bees. And for example, coming out of cold storage, you can see that it's a pretty significant difference in seams of bees. And then also that continues through almonds. We also looked at brood area. We do see a very slight effect of diet on brood area for hives coming out of cold storage. So here on the y-axis, this is not seams of bees, this is frames of brood. Okay, everything else is the same though. At this pre-almond time point, you're gonna have to put your glasses on. There was a very, very slight bump, okay, of the hives fed the global 4%, and it actually only amounted to about 1/4 of a frame, okay? So I don't want to say that because something is statistically significant that it's biologically meaningful. However, it's possible that this could be a meaningful jump going, of that population going into sort of your times of rapid growth. And it's interesting because this increase in brood area, or this difference in brood area that we did see, this did not persist beyond that time point. So we did not see any differences in brood area between hives fed the positive control and each of the diets. Okay. However, mites in August did predict whether, or did predict frames of brood. And again, we saw this pattern where hives that were above 2% infestation in August had less brood coming out of cold storage and in almonds compared to those where their mites were controlled. And again, this is even when mite counts were under this threshold or were controlled in September in all of the hives. So to summarize the diet effects, we did see that diet influences bee population in this larger data set of like 350 hives. After almonds, the hives fed the global 4% were trending at least more seams of bees than the positive control. We did not see an effective diet on adult population in the smaller data set, and this could be due to smaller sample size. It could also be due to the fact that these other factors are more important in this group that we measured, things like mites. We did see that diet may affect brood area coming out of cold storage, but the difference was very small and goes away after they've been in almonds for 3 weeks. So you could look at that and say, well, this could be an important bump as the hives move into the spring and summer growth period. And maybe that's true. We also wonder if this could have contributed to the greater seams of bees in the hives, or the higher number of seams of bees in the hives that were fed the global 4% patty, where we had information from all of the hives. So overall conclusions. Unsurprisingly, you have to control your mites, but you have to control your mites as early as the middle of August, because we did see that you have to get them below 2% infestation, the mite levels below 2%, to have stronger hives coming out of cold storage and in almonds. Hives fed in the fall and put into the cold storage, some of them, or in general, they did grow in almonds. If you just took all the data together, pulled everybody together, they did tend to gain an average of 1.2 seams of bees. However, if you separate the diets, it seems that this may not just be due to cold storage, and that colonies fed some diets may do better. and sort of to get at this idea of cost, okay? That's why I showed you the different price tags in the beginning. What we're finding is that it's not necessary to spend a lot of money to realize gains in the spring. This global 4% was actually the cheapest diet, and they tended to be the most successful coming out of almonds, or coming out of cold storage and going into almonds. So that's something to consider. And also to, I guess, the title of the talk, I talked about a comprehensive analysis. So the question is, did I achieve my goal? Was this actually comprehensive? I'm not so sure. And I think that rather than calling certain diets winners or losers, I do think that we have to take into account factors like season, location, weather patterns, things like that, and also obviously mite control when we're thinking about, you know, what to feed our bees. And so I think what this does do is it motivates a future look into these factors like season, location, climate, as a way to eventually get to a point where we can make, you know, good recommendations about what to feed your bees, no matter what time of year it is and where you are. And that's eventually our goal. And so with that, I do want to thank everybody again. And I think we will be taking questions at some point in a bit here.
Yep. Thank you so much for your presentation, Vanessa. And I think we also have Blake Shook, who is a collaborating beekeeper with us tonight. And I would just like to invite Blake to say hello and maybe a quick word about what it was like to be a part of the research process.
Yeah, thank you, Grace, and Dr. Corby-Harris. Thank you for that presentation, and thanks for the opportunity to work with you guys. I mean, it was a really interesting process for me as a commercial beekeeper to watch them work and to kind of see the process, and it was a very smooth process. And I was really eager and excited to see what the results would be. I mean, these are questions I've always had as a commercial beekeeper. You know, it is the diet that we're feeding and all the tens of thousands of dollars we're spending on pollen substitute, how beneficial is it? You know, what are the results? Which brand do we use? When do we use it? And so I would just like to thank you guys for you know, doing this practical research. I mean, you even showed the price of each pollen substitute, the brands, the amount that we put on, and that's very practically beneficial to us as beekeepers to understand, not in a theoretical sense, but in a very real sense, you know, which direction we should be heading and what trials we can start running more effectively in our own operations. So that was very, very, very helpful. You know, I had to give them a huge shout out for being incredibly flexible and forgiving amidst the chaos of commercial beekeeping. They were so patient, and you know, it proved to be a lot to track 400 hives as they move so many times across so many areas. And I think we sent them on more than one wild goose chase through almond orchards trying to find them. So they were really patient, and really appreciate that. Some quick background on our hives and kind of what we did, and watching this as it was coming out of my own operation was really interesting because you know, some things like the varroa mites were very interesting to see the difference it made. For us, you know, we don't pull honey until August, and so, you know, once we pull that honey is when we treat for varroa mites. And so that encouraged me to look at, you know, maybe we should be trying to find a mite treatment that we can preemptively apply before honey's pulled, that's safe to apply when honey's still on the hive, because you really saw a huge difference, like with the longevity of those hives based on when we got those mites down to zero. So that was super interesting. And we usually pull honey in the first or second week of August, and then we treat for varroa mites right away. And usually in late August through late September, we feed 2 to 4 pounds of pollen substitute. That's kind of our normal routine. And then that's the only time of year we feed pollen substitute. So, it certainly makes me want to do more studies, and I'd love to risk, maybe perhaps next time, risk 60 hives and do a control without any pollen substitute and see what happens. But overall, yeah, great to work with you guys and a great experience. Yeah, happy to answer any questions anybody has to.
Awesome. Thank you, Blake. And again, thank you, Vanessa. We do have a couple of questions trickling into the chat. Don't be shy. We've got a few more minutes for questions. We did have a question for you, Blake. Beekeepers are wondering what you used for your mite treatment in August.
Yeah, so we use we rotate. So every year can look a little different depending on what time of year it is and what's being used. Oftentimes in the summer months, when it's really hot, we'll use like an Apivar amatraz-based treatment that isn't heat sensitive.
And then I'll direct this towards Vanessa, but why not include a control group that includes bees fed their own honey during cold storage?
Well, everybody did have some honey going into cold storage, and that was their own honey. So we were only manipulating the supplement. So that's why we didn't look into any relationships between amount of honey and things like that. But we do have that data, and we can look at that too.
Great. And while people are getting their questions ready for the chat, I'm going to pull one from the registration form. Should beekeepers be collecting or striving to collect their own pollen to make their own pollen substitute?
I would say yes, that's probably a good thing. Even a little bit of pollen is good. The interesting thing is, though, we do know a lot, maybe not a whole lot, but we do know something about what happens when bees are going into winter. And it's important to have that decline in the amount of pollen as they're going into winter. And so that's why I think that a patty, when I say global 4%, it has 4% natural pollen in it. And so I think that it actually performed a little bit better than the positive control because it had less pollen, but it did have pollen. Okay, so it's sort of simulating that going into the winter, resources are kind of going away, but and so that's why I think that one performed a little better than the others. So yes.
And Blake, maybe if you could explain just briefly, what is cold storage and how does it compare to a Canadian winter?
Yes. So my experience of Canadian winters is it's quite cold for extended periods of time. And so cold storage, we send our bees to a shed in Idaho, and they're basically, a shed isn't really a great term to use because they're very much atmospherically controlled facilities where the temperature is controlled, the oxygen levels are controlled, CO2 levels are controlled, and it's all controlled to be kind of perfect for bees hibernation. And so they're held at about 40 degrees all winter long, held at the right humidity. So it basically takes away all of that fluctuation that bees have out in nature. In the South, it's hot one day, it's cold the next. Bees go out and fly and wear out their wings, burn up a lot of fuel reserves, food reserves, and then it's freezing cold and they have to cluster really tightly. Canada specifically, you have incredibly cold weather for long periods of time where the bees have to cluster incredibly tightly, versus at 40 degrees, it's a loose cluster. They're clustered, but they're able to kind of move around the hive to access honey stores. So those sheds just kind of hold them in the perfect hibernation conditions, and they eat dramatically less honey. Somebody asked about honey earlier, and we actually do leave honey for our bees. And so most of the honey they are consuming, or a lot of the honey they're consuming, is their own over the winter. And we do feed some, depending, varying amounts depending on how dry the fall is. But a lot of the honey, we do leave a box of honey for them. And back when we used to overwinter in the South in Texas, it was nothing for a hive to go through 40 or 50 pounds of stored honey during the winter months. And in sheds, they eat more like 12 to 15 pounds of stored honey per month. And so, I'm sorry, in total during the winter. And so it's a much more efficient use of the bees' resources in sheds as well.
Excellent, thank you. And I've seen just a couple of questions about if you could state again why no negative control, and it actually sounds like that might be something we're open to for future research.
Right. Yeah. Thanks for letting me talk about that again. The reason why we didn't do a negative control was because we know that when we do not feed the hives in the fall, we have higher mortality over the winter in general. And we did not want to put, hives in danger when they did not technically belong to us. And so what we did was we made comparisons between a positive control and each of the treatments. But I think that it would be, if that was a possibility, like you said, Grace, that would be something to do in another study.
Yep. And so we are actually very close to the top of the hour. I think that we're going to have to take the rest of these questions offline. If you're open, Vanessa and Blake, for me to send these to you, and I can help get them back out to our attendees, since there's just been a couple of good questions coming in, but I know that we're at the top of our hour. So I just want to say thank you guys so much again for joining us. This is an incredible project, and we look forward to sharing even more as you continue to work on your data, Vanessa. And thank you especially for joining us, Blake and Tim.
My pleasure. Thank you.
Thank you.